time to practice lesson 3 for the scientific notation. All right, write each number in scientific notation. Where's the decimal now? The decimal now is right here. 1, 2 to get one number, one digit on this side. How many times did I hop? I hopped twice, and it's a big number, so it stays positive. Decimals here, which is where it goes, and let's see, that was a weird one. 10 to the 0 power. That would work. Sorry, it's a little sloppy. Let me fix that. Because that's just times 1, right? So that keeps it the same. That was a weird one. I should have went in order. Let's see. This one. Sorry. Okay. 1, 2, 3, 4. That was a really little number. Okay. To get one number to the left, keep all the other numbers, get rid of the zeros. Decimal is here right now. 1, 2, 3, 4. 1.5 times 10 to the positive 4, because that was a big number. 1, 2. Oops. 8.1 times 10 to the negative 2, because that was a little number. And here's a weirdo. This is in standard form right now, right? Put it in scientific means the decimals here, move it here. This is 4.5069. Need the numbers. Don't need that last 0. But I only moved it twice, and it was a big number. I mean, to think about it, process it back. If this was this number to the 10th power, you can put that in your calculator. This number times 10 squared, or 100, right? Moves that decimal back this way twice. That's where it was. So feel free to move back just to check, okay? Let's see, write each other in standard form. All right, let's go back the other way. So this is positive, so I'm going to, oops. This is positive, so I'm going to leave some room because I'm going to be going to the right. So I write that down, and then I go 1, 2, 3, 4, 5. Put a big old decimal. Just fill in the humps there, and I kind of like to rewrite it. 8700. There's 4 zeros in there, and put a comma right there. So 8.7 turns into 87,000 with 4 zeros. Typically, if that's a 5, then you're going to end up with 4 zeros. But if there's lots of numbers like this one, it's not just 4. So I don't know if you can go by that. But all right, this is 2.56 times 10 to the 3, which is positive. So we're making it a big number. 2, 3, 0, 2560. That is 2,560. All right, 9. Let's see, 9 is the same thing as 9.0, right? But we're going to be going the other way. Let me write it over here. 9.0. This is, so the 9's here, right? Whether you see the 0 or the point or not, but the 9 is here. And they just drop the 0 because it's not important. There's nothing there. So, but make it a small number. 1, 2, 3, 4. Fill in the zeros here. And that final answer is 0009, okay? Really small number because it was a negative exponent. All right, this really isn't scientific notation, but it doesn't say it was scientific to start with. It just says change it to standard, okay? So if it's here and this is positive, which way are we going? We're making it a bigger number, right? So 1, 2, 3, 4. Multiplying something by a positive exponent makes it a bigger number. So if it's 0.05 right now, it looks like it's going to turn it into 500. I'm going to check that one in my calculator. Just to make sure, we have 0.05 times 10 raised to the 4th power. Yep, is 500, okay? Some of these are quite easy to put in your calculator. All right, we have a 60, but we're going to make it small. So 60 has a decimal here. Let me say that again. 60 has a decimal here, and we're going to make it small because it's a negative exponent. So 1, 2, 3, 4, 5 moves the decimal to over here. Fill in the zeros. So our final answer has 3 zeros here and a 6 right there. Okay. This is 2 times 1. That is 2. Okay. That's what that one is. Okay. All right, now the hardy bits. So this times this, 9.84 times 0.5 is apparently 4.92. I should probably check these things. Know me. Get my calculator here. 9.84 times 0.5 equals 9.2. Okay, 5.4. So that is in proper form because it has only one decimal on one side, on one number on the left side of the decimal. All right, and then we have to process the 6 plus a negative 10 or 6 minus 10, however you want to say that. That's 10 to the what? Negative 4, however you slice it. So our final answer is 4.92 times 10 to the negative 4. Done. Okay? All right, this times this, 5.26 times 3.16 equals, let me check in my calculator, 5.26 times 3.16 is 16.6216. Keep all the little parts, okay? At the end, we will round when necessary, so keep as much as you can. In statistics, we keep 6 places not rounded, 5 places rounded, so try to keep at least 5 places rounded properly. Should be good. Okay. All right, and then it was 10 to the negative 15 plus 18, so that's 10 to the 3, right? All right, so this one isn't in scientific notation because it has 2 digits on the other side. So I want to go 1.66216 times 10 to the positive 1, because that was a big number. It wasn't a little number. I mean, you know what I mean, right? So I forgot to put this in here. So that's plus another 1. Is 10 to the 4th. So this is 1.662, because this is round to the thousandths place, which I forgot to do on the key apparently, times 10 to the 4. Let me fix that on the key. You can't ignore rounding instructions. Okay. All right. Because that one you can't do in your calculator. Those numbers are too big. So make sure you follow the process, okay? All right. What is 4.9 divided by 2.7? Calculator. 4.9 divided by 2.7 gives me 1.81481. That's at least 5 decimals rounded properly. After the 1 is a 4, so that is properly rounded to the last digit of 1. And then I have 10 to, and there's 1 digit, so I don't need to do anything else. 10 minus a minus 3 is 10 to the plus, is 9 to the plus 3, which is 12. So this is 1.815, right, rounded to the thousandths place. We look at the 8 and the 4. So 8 is large, so 5 and above, round up. That isn't the saying. 5 and 5, more than 5. 5 and above, round up. Oh, I don't remember the saying. I'm sorry. Just drawing a blank. I saw it somewhere and I wrote it down. It's not my saying, so I don't remember it. But I remember. 5 and above, give it a shove. 4 and below, let it go. There you go. It's a good saying. I just can't remember it. All right. So times 10 to the 12th. 5 and above, give it a shove. 4 and below, let it go. All right. 5, let me check this one. 5.33 divided by 9.62 is 0.55405.4. That's not in scientific notation, so I need to move it 1. 5.540.5. That was a 0, so that's still a 4. I'm eventually going to need to round it to the thousandths, though, but right now that's that. All right, so 10 to the negative 6 minus a minus 2. Don't forget to do that. That's 10 to the negative 4. So this number, rounded to the thousandths place, times 10 to the negative... Ooh, what'd I forget? I moved this thing. Which way did I move it? I moved it that way. So hang on. That's 10 to the... We're adding these, so that's 10 to the negative 5. So that's 10 to the negative 5. I almost forgot. Okay?